cylinder. Let's do cylinder. Aux wire cylinder. Wire cylinder. And we are doing cylinder. Let it be of size of radius 2.5, and with the height let it be 3.0. After this, we are checking our model, how it works. I'm starting, I'm trying to see the result. Oh, we have something. We have some cylinder. It works. Okay. So the height of this cylinder is 3.0. Before you are doing something, you should save your coordinate system. You can save it by GL push matrix. And in the end, maybe you will come back using pop matrix. So it means that you have saved coordinate system, but by push matrix, but by GL pop matrix, you have returned back. To make some orientation, to see where is your axis, you have to do coordinate system. Coordinate system we can get from our examples, really. So we can select, for example, lecture 13 from OpenGL, and let's look. Maybe there is some examples of coordinate system. There is no example of coordinate system. No example of coordinate system, but maybe there is some example of coordinate system. Here points not very good, but there is our example of coordinate system. Okay, we will do it from the beginning. GL beginner, GL lines, and it will be finished by GL and now we are doing lines. How to do line? Lines are provided by independent points. So vertex, GL vertex to 3i from point 0, 0, 0 till point on x-axis, GL vertex, also 3i, but maybe 5, 0, 0. So it's some point on line x. The same for other axes. Oh, and before we will define the color, GL vertex 3i, and again GL color 3i, 3f, GL color 3f, let it be red, 1.0, 0.0, 0.0. So we will have three colors. We will have three colors and three lines. One is X. It comes from 0, 0, 0 to point 5, 0, 0. It's for x-axis. For y-axis, it goes from 0, 0, 0 to point on y-axis, so to point 0, 5, 0. And for z-axis, it will be 5, 0, 0, 5. About colors. Colors also will be different. Here 0, here 1, it will be green, here 1, it will be blue. So we will have three axes. Now, before our object, we will have axis. Oh, we have axis. So what can we see? We can see that our cylinder, first of all, very big, and we should do it smaller. And also it's slightly maybe down or up, then we need. So what can we do? Let's do it smaller. First of all, let it be of size maybe 1.5 or maybe 1, and with the height 2. With the height 2, it will be our initial cylinder. Oh, it's smaller. Smaller, maybe we should shift it down or shift it up. Let's shift it up. Let's shift it up. To shift it up, what we have to do? We have to use translate, GL translator, along y-axis 1.0, 0.0, and let's see 3F here, GL translate or GL translate 3F. What's the problem? GL translate F simply without 3F. GL translate F. Oh, it's better. It's just stands on axis on x-axis. Yes. What's next? What's next? According to our picture, where is our picture? Next element should be a rectangle. A rectangle which is a box standing on our cylinder. Yes. So next we will do box. Aux wire box. What it will be on size? Seems it should be slightly less than our cylinder, but let it be of the same size. 1.0, height will be maybe 2.0, and z coordinate, let it be the same like x. So we will also have a box. Initially it will be maybe in its incorrect position, but we will correct it. So we can't see it. Maybe it's inside our cylinder, so we should shift it up. So to make it more correctly, we'll shift it up. Adding the GL translate F. Also using this translation, we will elevate our box more up. So now you can see it's up. Yes. Students, are you here?
Yes.
Yes. So easy to understand how we are doing this.
Yes.
Mm-hmm. Yes.
Mm-hmm.
Yes. Yes. So it's still not normal. Yes. It should stand exactly maybe above our cylinder. So we will add additionally more translation along z-axis and along y-axis. So maybe I will set free here. Maybe I will set free. Oh, it's too much. Too much, yes. Maybe it will be one, no. Let it be here. Let it be 2 here. Maybe 2 will be okay. Looks okay. I don't know. Maybe it's good. Good or not good? Yes. It seems it's okay. What do you think, Noor? Is it okay?
I think so.
Let it be for our simple case. Let it be okay. No. Certainly interface of this program not very good because it gives us some unexpected rotation. We need not any rotation, we need a fixed object, but we should find moment there to fix it. Oh, interface. Oh. Oh, something we have. Okay, what's Nur? According to our picture, what's next element? Let's come back to picture. What next element we have to do? Nur, can you see this picture?
Yes, yes.
Yes, what's next element should be? So we did what? We did the base. So the bottom picture, it's a look from the top. A look from the top to our robot. The hatchet space, which is a part of circle, yes, it's an area of robotic arm access. So it's an area, then their objects are possible to get. So it is not robot itself. Robot itself, it's only cylinders, boxes, and so on. The hatchet area, it's not robots. It's a picture there, the area of access. Okay, so next should be a cylinder. If to look to the upper picture, we have to do cylinder which is perpendicular to our box, Okay.
Okay.
Okay. So let's do picture. Let's do another cylinder. So we are doing another cylinder. We are doing another cylinder. I think it should be quite thin cylinder. Let it be 0.3 nearly. And length, let it be 1.0. Length 1.0. Oh, you can see, yes. What's not good with such a cylinder? What we have to do, Nur? What we have to correct?
To make it up?
To make it up and to rotate it, because it should be perpendicular.
Yes.
It should be. We should extend its size. It should be longer, much longer. It's not enough, and we have to rotate it. Along a z-axis, I think. So first of all, we will rotate and we will extend its size. So let it be, its size will be nearly, how many? Let it be 3. Let it be 3 or maybe more. But before we will display this cylinder, we will make rotation. GL rotate F. It should be rotation around 90 degrees. 90 degrees around z-axis. So what does it mean here? In every rotation command, first parameter, which is highlighted, it's an angle of rotation. Rest 3 parameters is the axis of rotation. So 0, 0, 1 means rotation around which axis?
Z.
Z. So if you will write 0, 1, 0, it will be rotation around the y axis. It will be, if it will be 1, 0, 0, it will be rotation around x axis. Let's see the result. Okay, you can see we have some picture, yes? Some picture. Maybe not enough length, but looks better. Looks better. Looks better. Something like this. Maybe we'll extend its size. We will extend its size. So maybe not 3. Let it be 5. 5. So it will be our model of robot. Certainly, to make accurate model of a robot or other objects given in this picture, certainly we should do more, yes, because real models are more complex, but we are doing not a very accurate model. Our task is to make something similar to real, similar to real. Oh, how to stop it? Something like this. Okay. Do we need to add more elements to our robot? Maybe we should do a back cylinder, which is short and thicker than the basic cylinder of this perpendicular arm. Let's do other elements. So currently we have rotated coordinate system, and we have this cylinder. So we really need 2 cylinders. One is a thick cylinder, which is on the rear of on the back of our basic arm cylinder. So how can we do it? We can apply. First of all, it will be shorter. Let it be 1 on its length, and let it be more thick. Let it be 0.4. But also we should shift it. We should shift it to the negative rotation. So we will apply GL translate. GL translate F, and we will shift it negatively along z-axis. Let it be 1.0. Certainly, maybe it's not accurate, but first of all, we should check it step by step, and oh, it's just okay. You can see, Nur. Can you see it?
Yes, yes.
It's good. Okay, just okay. And also we need one small cylinder on other opposite side of this arm. So, by the way, I thought it should be negative translation, but it looks that positive was very good here, in this line. In this line, GL translate. So we should now go to opposite side of our cylinder, of our arm. So, oh, just a moment. So we'll shift maybe -5, and we will do another cylinder. Control V. It should be thin. It should be maybe 0.1, and also small height. Let it be 1. So let's check again. Oh, so how can we correct it? What do you think about correction? Nur, what do you think about correction? It's still inside the cylinder, yes? What can we correct?
To make it outside.
Huh?
To make it outside.
Yes, to make it, but how to make it outside? What we have to correct? What command we have to correct? I think the size of our cylinder is okay, but maybe its position not okay. Position in our case is changed by function GL translator. It translates F, translates. Maybe we have to change the value of translation. Currently it's -5, but maybe you will propose other value. Nur.
It should be minus more than 5, I think. I don't know.
Yes, but what value can you propose? Now it's -5. Just a moment. Да, Анатолий Михайлович, у меня сейчас лекция. Я видел, что вы присутствовали, так что все нормально. Да. Ну ничего страшного, вас же никто не спрашивал, так что все нормально. Ну где-то после часу позвоните. Хорошо, хорошо. Sorry. So let's change how calculations are here. The length, the height of our last cylinder is 1. Yes. Currently looks that it's completely inside our basic cylinder. Yes. So maybe we should translate it to its whole size. So -5 we will change to what? Let it be to -6. To -6. To -6, and now you can see such figure. Such figure. And now we can rotate it. So such model of our robot. So what questions do you have? Nur, what questions do you have? So it's a task of our second lab. Students, what questions do you have? Nur, do you have questions?
No,
there is you. Do you have questions?
No.
So really you have to repeat. Do you have some working project? Nur.
What's that?
Do you have OpenGL project which is working?
Yes.
Yes. So you have to try to include this code. I can copy this function, or I can send it by email.
Yes, I'm gonna try and try to do another example.
Yes, you will try as an example, but just now you can make a screenshot. It's the simplest, maybe. How to do this? To make it smaller on screen. Such examples are they can be done in the same way. Such examples. So the whole function, I will delete this t-port. So I will extend slightly. So now you can see the whole function. Yes. This part is responsible for clearance of previous pictures. This part supports the rotation by keyboards, arrow keys, This part is responsible for the axis because we have to see how our object is located in a space. And last part, starting from push matrix ending to pop matrix, really how many? It's 10 commands, yes, and everything is provided. But you should remember that every command, like GL translate, it transforms your coordinate system. Your original coordinate system is really hidden somewhere in OpenGL. With which coordinate system we should work? I think as our coordinate system, we should look our coordinates, our axis. It will be our initial coordinate system for this particular function. Then command GL push matrix, it stores our current coordinate system to the memory. So we can come back to this coordinate system any moment, and really, in this example, all the objects are constructed one by one. So initially, so maybe, can you see me? So how can I explain it? So we have, for example, first object, and the coordinate system is in the base of this object. Then coordinate system is shifted up, and we can do our next object in second coordinate system. So it means that our new coordinate system is in the base of the second object. Then, for example, we want to do some additional object. We can do it vertically, for example, with pencil. It will be coordinate system shifted from this point to this point. But if you want to rotate, we should make rotation of coordinate system. And it will be from this coordinate system, it will be rotated to this coordinate system. But maybe its location will be not good, so you have to shift this coordinate system. So you are working with the several coordinate system. But by pop matrix command, you can back to the original coordinate system. Okay? And all the corrections of our coordinate system are provided by translate. It's a parallel shifting of our coordinate system. So, for example, it's along y-axis to value 1.0. You did first object. Then again, you're shifting again along to along y-axis again 2.0. So we are shifting more from your original coordinate system. Then you're rotating 90 degrees. So it means that you are currently in the rotated coordinate system. So it means that after rotation, so you are in the rotated coordinate system, and your y is now looking here. It's not still going to the up, it's going to the left or to right. And so that's why a shifting of y-axis here really will be translation along this axis, and currently z-axis possibly looking to me, and so on. So you have different translation, and you should fill with translations. By the way, we can repeat, for example, our axis. It's not very good idea, but I simply want to show you. There will be our coordinate system after rotation. I will do a small coordinates, small axis length of axis. So you will simply see that you have constantly a lot of different coordinate systems. A lot of coordinate systems. So you can see that we have a number of coordinate systems, yes? So our initial coordinate system was in the base of our first figure. But now our coordinate second coordinate system is looking to other directions. So your y-axis is along negative direction of the cylinder. Our new x is going to up, and z really is going to our standard direction. Only z is looking to the old direction. Okay? Students, where is you?
Yes.
What yes?
Understand.
Huh?
Understand. Yeah.
So what will be result from the coordinate system point of view? What's the meaning of translate or rotate? What translate do? What rotate do?
Rotate.
Rotates what?
The object.
Not object. It rotates coordinate system.
Coordinate, yes.
Coordinate system is rotated, and you in this rotated coordinate system doing your object. Object every time it has some standard direction. For example, cylinder is always directed along y-axis. So how to make, for example, perpendicular direction of cylinder? To make coordinate system in such way that your y-axis will be, for example, in the needed direction. For example, your new location of coordinate system is such that really your new y-axis is parallel to old x-axis, you see? And it shifted up. Can you see this small green line in the top? No?
Yes.
Yes, and you can see that small axis x is going to up. So we have rotated our coordinate system, we have shifted it up, and we have rotated it. So using a shift of coordinate system, you can set your objects in different locations. So it's the same for all the tasks. By the way, about your course projects, they are the same, but possibly the titles of your course project are complicated by what? They're complicated by application of textures, for example. So you should make some colors of your objects, not simply flat colors like green, red, blue, but maybe some pictures like picture of steel, picture of plastics, something similar to real objects. So do you have more questions about this example? No.
For me, no.
For you, no. Okay. Students, who else is here? Students. Somebody asked. Can we use GLUT with MFC in the same project? Yes, we can use GLUT. We can use. any libraries are combined. The problem is what? As I understand, for example, aux library does not work under .NET. It's a problem, yes, because that's why last time we have considered how to do this project in Glut. Maybe let's try the same in Glut. I will simply copy the code from this project, from this callback. I will copy and we will open our .NET project and we will try to make it like in Glut. So Control C, I am closing this project and I will open .NET project. My .NET project was project 44, it's last time project. The same definitions, but instead of aux, we are using glue and Glut. So our last function called here was onPlane. OnPlane we need not. Let it be onRobot. OnRobot. OnRobot should be defined like a global function. Void onRobot. And in the down of our code we will do function onRobot. So I have copied this display function from previous so I delete something. What's the problem here? For example, box does not work. Maybe box will be working on Glut. Glut works or not works? Possibly not works. It's bad. Glut wire cone cube and that's all. Torus. So we can't. Or cube. We can do cube instead of. We can do cube. Cube will be with which size? Let it be size 2.0. Sorry. Sorry. So we are changing our Glut, our aux to Glut, if it's possible. But the biggest problem here is cylinders. We have no cylinders. It's bad. So what can we propose instead of with cylinders? We can try glue cylinders. glue cylinder. But glue cylinder really needs other parameters. Which other parameters? Which other parameters? We did it last time. So first of all, it needs pointer to so-called quadric object. So we are doing pointer to the quadric object in the beginning. Oh, what's this? It should be on robot. On robot. So quadric object, MQ object. So MQ object should be here. MQ object, comma, base radius, top radius 1.0, and number of our forming lines. So we are doing our first cylinder. So about other cylinders. So we are copying our title, Control C, and we are replacing existing. So 1.3, 0.35, 30. Here the same. I'm trying to correct. 0.4, comma. So what is the specification of this command? MQObj, it's a pointer to the so-called quadric object. Then you should set bottom base radius, so-called base radius, then top radius, because really using cylinder command you can do as cylinder itself, as cone itself, or cutted cone. So we have more options from one hand. So we are trying to transform it. Certainly, we possibly will have problem with the location of our cylinders, but from syntax point of view, everything is okay. Syntax point of view. What do we have now? We have such object. You can see the location of our object is not correct. Location of our object not correct. We have cube. So we should build it step by step, seems. I think we will comment this part because it's not correct. We will comment this part because it's not needed. But we will deal with the first part. So we have cylinder and we have a loop. What's the problem of our cylinder? It's looking not to the correct direction. It should be rotated, and should be rotated around the x-axis. So before we doing our cylinder, we will delete translation. We should rotate it around x-axis. GL rotate. As you see, every time we want to do something, we should check it step by step. Maybe it looks not very effective, but it's the only way. It's the only way. So we have cylinder. But it looks alone what? It looks alone y-axis, but in negative direction. Maybe we should shift it in the positive direction. So we have rotated. Now we can shift it. GL translator 0.0. Let it be 2.0 here. 0.0. Possibly it will be in the right position. Possibly it will be in the right position. Yes, looks it right. But the position of our cube, oh, not very right. Not very right. Maybe we should initially shift and then rotate. Just a moment. So we will firstly shift and then rotate. Okay. So step by step, everything is done step by step. Oh, cylinder is okay. Cylinder is okay. But cube is not okay. It's shifted. Maybe we need to exclude with shifting. Let's exclude shifting. So we have excluded shifting, but shifting along z-axis, along y-axis not enough. So we will shift it more. And we will decrease the size. So along which axis we have to shift? Along which axis? Possibly, oh, it's better. Let's shift again before cube. Possibly it will be along y-axis, and it will be good. Not along y, it's x here, along y-axis or what? Or along z. Let's try z. The problem is that every time you are changing something, so it's inside, I see. Is inside our, yes, it's inside. It's very difficult to understand where is our axis. It's a problem. So let's shift it to maybe 3. Maybe it will be out of our cylinder. It's too much. Let's do 2. So in such way, step by step, changing one object, changing other object, we can do our result. It's just okay. But we need half, I see. And by the way, negative direction, minus cylinder, our height is, let it be minus 3, minus 2.5, let it be. Minus 2.5 will maybe give us a good cube. No, too much, too much. Minus 0.5. Looks okay. Looks okay. They are joined, our cylinder and our box. Now the task will be how to do our cylinder, new cylinder. But before we should see where is our coordinate system. Is it good? Is it good? So now we will see where is our coordinate system, and then we'll decide what to do. Our coordinate system is here. So it's not rotated, I see. Not rotated. X is rotated. Exactly. Y is rotated. So we should make our cylinder along y-axis. So like in our previous case, we will apply function GLRotate. Oh, maybe we already have it. And we will do our cylinder, but smaller cylinder. Such smaller cylinder. So in the rotated way. Oh, it's not rotated. Or rotated along a wrong direction. So what we have to do? Let's rotate around that. Oh, I did a wrong action. I did wrong. So we have to rotate here around axis. Oh, looks okay. Looks okay, but you can see it's shifted not okay. So after rotation, we should shift it. So we will use GL translate F, and let's shift maybe to the same, maybe 0.0 minus 2.0, 0.0. Oh, it shifted too much. Shifted too much, not to that direction we need. Let it be minus 2 on x-axis. Certainly we can support every our rotation or translation by making of our coordinate system. It's not again good So we have only that. Maybe that will be the only best variant. Students, what questions do you have? Because we are doing something, but I have no any response. So it's what's not good here in .NET, that refresh is not very, yes.
I think the other shapes at the back is not well seen due to what we took the solid color, I think.
Solid color for what? For the box?
Yes.
We can use solid color, but I don't think it will solve our problems. Solid color for the different colors, first of all, we can use. We can change glued Y cube to solid. And let's change maybe color. Let it be red. GL color free F. Where is free F? And here let it be red. 1.0, 0.0, 0.0. Cube will be solid, but I don't know, really good. So, by the way, if we have defined some color, everything after this color also should be. But
I think
it's better. I don't think
yeah,
it's
better than the first one. Yeah.
okay. But refreshing is not good.
Yes.
And the color is transparent. So our cube is transparent. But you understand that in this way, step by step, you can do your program better and better. Okay, what are the questions on this question of second laboratory work you have? What are the questions?
The question states that wait 1 second.
At second laboratory work, what questions you have?
I'm coming with.
You have no questions?
No, I have one question there with.
Yes, okay, ask me question.
I want to go to the actual question. Oh my goodness, what is this?
So again, we did our project according to the picture. Here it was console arm to PTP. So you see there is a cylinder in the base, and then box installed on cylinder, and you have perpendicular other cylinder. Maybe in school you have such subject like technical drawing or technical painting, something like this. So it's like technical subject, how to see object from different sides. So it's an example that object is shown from different sides. The upper picture it's looking from side, and second picture, bottom picture is looking from top. So, for example, upper picture is looking from right point, from a point which is located right of our object, and the second it's looking from top. Okay?
Okay.
So we can go next?
Yes, sir.
Okay. So it was lecture number 14, but we should go to lecture number. Certainly, I feel that there is still problems what project to select as a basic.
Yes,
Or not?
because that one I wanted to talk about it
Yes, let's talk about it.
for the project.
So what project you have to select as a basic?
For
Similar.
me, considering about I don't know anything about the one that we did on the .NET, that ODBC, but
No, no, no.
I think the
ODBC,
console will be the best way for me.
ODBC is only for course projects. It's not about OpenGL.
Yeah, but as I that's why I say like the concerning about the course project, I think I'll work on OG. No, I'll work on the how do you call it? The OpenGL than the ODBC, because that one is hard.
So if you want graphics, if you want some pictures of robots, you should select OpenGL project. So currently we are talking about OpenGL only. Later, then we will finish with the textures. We will talk about ODBC.
Okay.
Okay. Who else is here? Students. Daniel. Daniel wants to ask.
No.
Daniel, do you have questions?
I wanted to ask the question somewhere else, but someone already answered.
Okay. So we can. Michael has. Michael Ali Salem.
No, sir. You've already answered the question.
Okay, let's go to maybe 15th lectures. No, not 15. It should be 16. Lectures 16. So the texture is the textures. I think it should be about the textures. Texture mapping. Why do we need some textures? Textures should make our computer model more similar to in its view to the real model. So we have computer models, and we have real objects which are described by this computer model. The problem of computer models that computer models are not the same like real objects. Certainly, you can say that the view is not real, but trying to make our objects better, I think we can find a way that on size our object will be similar, very similar to the real object. Our computer model will be similar to our real. But what to do with color? The flat color, like we did just flat color like red or blue or other colors, they are not real. Our objects have different colors. It can be a problem. To describe the real picture of the object. So I have no any objects around to show you. What can I say? For example, we have picture of some book, maybe some book. I will show you. For example, if you want to make a computer model of book, yes, so we can use, for example, some rectangles, or maybe you can use some 3D cube or box, but you can get a picture of real book. You can get picture of real book. For example, this is a book is about ancient Romans, about Rome Empire. So you can get real pictures from this book. You can cover this picture of real book. You can use as a cover of your computer model. You can locate in different positions. You can rotate it here, here, in other different positions. But your computer model of book will be covered by a real picture. Just the same, but more complex is in graphical programs. What is the purpose of these programs? So the most popular of this, the most popular sort of this program is the computer games. What in computer games? For example, hero is going through some way in the forest, or maybe in some rift, maybe in some labyrinth. So some hero is going. Yes, what should you describe? You should describe some floor as a grass, for example, green grass. Maybe you should describe your corridor, walls of this corridor. These corridor walls should be covered by colors similar to real. The quality certainly of these walls can be different. It can be simple colors, or it can be pictures of real objects. So it depends a lot of it. Certainly, textures. It's a call of, it's a title of objects which apply to make our computer object more realistic. Texture. It's a picture. Which is applied. Or which covers the surface of computer model. Our computer model, for example, of our robot was covered only by what? If we used wire versions of our function, for example, aux via cylinder or glut via cylinder, it's used only some flat colors, but instead of red color or green color, you can use the picture of your real object. For example, you can make shot of your photo of your wall in your room, or you can do a picture of your table, or you can do, for example, picture of your book you want to display. So to make model, you need to collect a number of pictures, and you should cover your models, computer models, computer model of walls, of floor, by different mixed colors, or colors displaying real objects. So that's why we are talking about textures. How can our textures be? First of all, our texture can be one-dimensional. What's a one-dimensional texture? One-dimensional texture is like a thread. So it's like one line. So this is a pencil, yes. But if you will cover this texture, this pencil by different colors, it'll be colored pencil. For example, old old pencil is damaged. It's damaged, and here in the center something like green color. Here is damaged, so it's only color of wood. So it's a real pencil. But to do with a real pencil, what you have to do? A computer model of this pencil. You have to make a shot of this color, and to use it to cover the computer model. If we will cover our pencil by different sides of this pencil to different colors, it will be a one-dimensional model, one-dimensional texture. For example, sometimes our pencil is white here, sometimes black, sometimes it's other color. So it's a one-dimensional texture. It's one of the examples of the texture. If you want to cover two-dimensional object, you can use a more complex picture. For example, like picture of the book. So you can make shot of this cover of the book, and you can use it for your picture. But the page, any page with the text, also can be used as a texture. Yes, and you can use with two-dimensional page also to cover other objects. For example, it can be objects on a wall. Yes, it will be two-dimensional. But if I will bend my two-dimensional page, it will mean that it can also cover cylinder. Yes, also cover cylinder. So two-dimensional texture can be applied for simulation of also three-dimensional objects. So we have one-dimensional textures, which is like pencil, colored pencil. Two-dimensional texture, like, for example, with page with the written text. But two-dimensional texture can be applied as for two-dimensional, but also for three-dimensional objects. And the more complex figure, it's a three-dimensional texture. What's a three-dimensional texture? Three-dimensional texture is a picture which has irregular manner in all three dimensions. For example, this is a piece of paper. Yes, it's a two-dimensional. Yes, so we can cover our book by this two-dimensional texture. Yes, but can we apply it for three-dimensional object? Yes, we can cover, for example, my phone, which is a three-dimensional, by this two-dimensional texture. Maybe it's not very good example, but it can be it can cover. What about, what's the question?
No, I said okay.
Okay, but how to make it three-dimensional? To make it irregular, it will become irregular on different our coordinates. So our three-dimensional texture became our two-dimensional texture became irregular on all the coordinates. So now it's a three-dimensional, and we can cover our three-dimensional texture by our three-dimensional texture our two-dimensional objects. For example, if you want to simulate to some areas of Earth, to simulate maybe car driving program simulation, or flight simulators, or maybe other simulators, we will need as two-dimensional, as one-dimensional, and also with simple three-dimensional textures. So in any case, it's a picture which is applied, which is covered by. It's a picture which is covered by, which covers some surface, and certainly the level how it's detailized will define the functioning of your program. But I should say that then more quality you will define for your texture, then more slow your program will be, because it has effect for our textures. It's very pity, but we have few time. I will shortly say about other commands to describe textures. Certainly, commands to define textures are quite low level. Lower level, what I mean? I mean that they have a lot of different parameters. You should understand that OpenGL is not 3D maps, yes? So you can't manually move, combine, or delete some objects. We should only write program. What is here? For example, what do you need to define two-dimensional texture? Two-dimensional texture like picture, like cover of our book. We have to define the type of texture. In case of two-dimensional texture, it should be 3D GL texture 2D. So it means that it belongs to OpenGL, first of all, with the prefix GL. It is a texture, and it's a two-dimensional texture. Then detailization level. Detailization level usually used, it's a scale how your texture will be defined. You can increase with scale or you will decrease the scale. Then format here is quite a big number of different formats. So the whole table, alpha, alpha 4, alpha 8, 9, 12, 16. These are all types of particular case, but in our case, we will use all the colors, RGBA. So it means 3 basic colors, red, green, and blue, and also alpha color, which means transparency. What about next? Next, you have to define the width of our picture and the height of our picture. Also, you can define border, so it means the frame around your texture. Format should be also GLRGB. Type of our information should be get from your picture, and pixels, it's a real picture which is inside your file. How we will build our textures? We will use real pictures. We will use real pictures in our program, or we will create manual pictures like with chessboard examples we will consider next time. Okay, what questions do you have, students? Did we simplify the understanding of the program today or not? Did we simplify something? Samuel.
Sir.
Did we simplify something today?
No, we are still on the second lab. But the other day, the one that we did like we still have the code that is functioning, but we need to add some small listing to it. Me and Fuad.
Similar, I think what you have to do, you should download one of the examples from the Google Drive, and you should try these examples. First of all, you should make your program working. Program with a teapot with some simple objects. Then it will work. You are trying to change step by step your object. You are trying to make one object above other objects, then to rotate they relationally. So to make more complex results. Step by step, it's only way.
Okay, so
Okay. So students, do you have some questions? By the way, tomorrow we have consultation at 11:15.
yeah, we will join.
So if you will have questions, so join to the same conference. The difficulty is that simultaneously tomorrow I will have an exam starting from 9 o'clock. But I will find time to answer your questions. Okay?
Yes, sir.
Okay?
Okay, sir.
So see you tomorrow, but that's all for today. Goodbye.
Okay.